So hello students. I hope all of you go through my last lecture. So today's class I'm going to discuss about the Newton's second law. So before I is going to Newton's second law, so you have to know some mathematical formula of differentiation and integration. Okay. So this formula you have to use in different derivation. Now, first we will discuss about the differentiation. First of all, what is differentiation? Differentiation means it is the rate of change of something. Okay, rate of change. That means, for example, the velocity. Velocity is what? Rate of change of displacement. Okay, rate of change of displacement. That means, if you write in differentiation term, then you can write. Suppose x is a displacement and t is time. So dx by dt is called velocity. Okay, that means it is the rate of change of this x is displacement with respect to time. Okay, how much changes with time? Okay, that is denoted by that is differentiation. Okay, another example, suppose rate of change of momentum. What is rate of change of momentum? Is force. Okay, that means it is a change in momentum with respect to time. Change in momentum with respect to time, or anything. That means the main thing is that differentiation is differentiation give us the rate of change of something amount with respect to another. Okay, there is the differentiation. Now, there is some basic formula in differentiation. First of all, there is ddx of x to the power n. ddx of x to the power n. If then what will you get? N into x to the power n minus 1. Okay. So for example, suppose ddx of x cube. ddx of x cube. So in place of n here is 3. So we apply the differential formula. First of all, n that means 3x 3 minus 1. So it will be 3x square. So ddx of x cube is 3x square. Okay, this is the basic formula. Basics. Now second formula is ddx of sin x equals to cos x. Okay, ddx of that means rate of change of sin x with respect to x is equals to cos x. Next you see ddx of cos x equals to here a minus kin. Okay, that means ddx of cos x equals to minus sin x. Again, next one ddx of log x. ddx of log x gives us 1 by x. Okay, ddx of log x equals to 1 by x. Next is ddx of e to the power mx. This is the exponential term e. Okay, e is the exponential term. So ddx of e to the power mx gives us the m into e to the power mx. Okay. Okay. Another formula is, suppose ddx of any constant c. ddx of any constant. ddx of any constant is equals to 0. Okay, any constant. Suppose ddx of suppose 2 equals to 0. Okay, so these are the some basics formula of differentiation. Okay, we will use this formula in derivation of various theory based formula. Okay, now come to the integration part. Integration part. Now what is integration? In a simple word, integration means sum of a small term. Okay, for example, suppose we take a rod. Suppose take one rod. Okay, if someone asks you to find the length of the rod, then you can directly measure by scale. Okay, suppose you don't have viscous, then what will do? Okay, we consider that this rod is consists of small part. This is one part, this is one part, this is one part, this is one part. Okay, this small part. So if you sum of the small part, then you will get the total length. You will get the total length of this rod. Or if this part is blackboard, okay, this blackboard, here you want to find the area. Okay, you know only a small area. You know only suppose small area of this board. Suppose this much area you know. So for finding the total area of this board, we have to sum up the small area. Okay, the small area. If you sum all the small area in this board, then you will get a total area of this blackboard. So this is the basic concept of integration. Okay, we can find the total quantity by using a small quantity. Okay, that means this is the we integrate the small term to find the total area. Now, come to the formula. First is integration of x to the power n dx equals to x to the power n plus 1 divided by n plus 1 plus constant plus 1 constant k. Okay, for example, suppose integration x to the power 4 dx. So using the formula x to the power 4 plus 1 by 4 plus 1 plus c, that means x to the power 5 by 5 plus c. So integration of x to the power 4 give us the x to the power 5 by 5 plus c. Okay. Now next one is integration sin x. Integration sin x dx is here minus cos x plus c. Integration cos x dx equals to sin x plus c. Next, integration 1 by x dx, we will get log x plus c. Okay, log x plus c. Next one is integration e to the power x dx, that means e to the power x plus c. Okay. Second integration, you got one extra constant term here. Okay. If there is no limit, that means suppose we don't want a limit. Suppose a integration given, suppose for example, suppose 1 to 3 x to the power 4 dx. 1 to 3 x to the power 4 dx. Then here what will get? X to the power 4 plus 1 by 4 plus 1, 1 to 3 plus c. So you have to put this value in place of x to the power 5 by 5. You have to put the value. Oh, here there is no c because here the limit is given, so we don't have to write the constant term. Okay, we don't have to write the constant term. So after you get this, using this formula, you have to put this limit. So what is the limit from 1 to 4? Here limit is 1 and 4. So first you have to put this upper limit. It is called upper limit. It is called lower limit. First you have to put upper limit 1 by 5. That means 4 to the power 5. Then minus lower limit x to the power 1 to the power 5. So you have to place in place of x or variable term, or you have to place the limit in place of variable term. Here variable is x, so we put the value limit in x. Okay, so 4 to the power 5 minus 1 to the power 5, so it will be 1 by 5. How much will got? Just like that. Okay, so these are the basic concept of differentiation and integration. Okay, now we will discuss about the Newton's second law of motion. So now I am going to discuss about the Newton's second law of motion. Okay, we already got in class 9. That is what is Newton's second law of motion. That the rate of change of momentum is directly proportional to the external force, applied on a body. Okay, so I have written here, it states that time rate of change of momentum of a body is directly proportional to the external force applied on it. That means when you apply a force on a body, then the body will displace. Okay, body start to moving. That means it will change its velocity. If the velocity changes, then momentum also change. Okay, এতিয়া তোমালোকে কোনবা এটা বডি ধৰি লোৱা কিবা এটা ফোর্স দিছা, ফোর্স দিয়াৰ লগে লগে কি হ'ব, বডিটোৰ পজিশন চেঞ্জ হ'ব, পজিশন চেঞ্জ হোৱাৰ লগে লগে তাৰ ভেলোচিটি চেঞ্জ হ'ব, ঠিক আছে, আৰু ভেলোচিটি চেঞ্জ হোৱাৰ লগে লগে মোমেন্টামো চেঞ্জ হ'ব। সো নিউটন সেকেন্ড ল অফ মোশনে কি কৈছে যে ৰেট অফ চেঞ্জ অফ যেটো মোমেন্টাম হয়, ওকে, হেতু কাৰ প্ৰপোৰ্শনেল টু কি হয়, এক্সটাৰ্নাল ফোর্স, যেটো ফোর্স আমি দিম বডিটোৰ, যেটো ফোর্সৰ কাৰণে বডিটোৰ মোশনটো চেঞ্জ হ'ব। Okay, so time rate of change of momentum is direct proportional to the external force applied on it. Now I will derive the this equation. Okay, equation of force. That means time rate of change of momentum is what? Suppose p is the momentum and t is the time taken. Okay, so time rate of change of momentum with respect to time, I will discuss about the differentiation. So we can write here dv by dt, time rate of change of momentum, f is proportional to dp by dt. Okay, so f equals to k dp by dt is k. What is what? This is the constants of proportionality. Constants of proportionality. Now we choose this constant 1. Choose this constant as 1. That means k equals to 1. So for k equals to 1, we get f equals to dp by dt. Okay, f equals to dp by dt. Now what is p? What is p? d by dt of what is p? P means momentum. Suppose we consider a body here of mass m. Okay, it's mass m moving with a velocity v. So p will be mv p is what? M into v, if the v is the velocity. So we know mass is constant. Mass is constant. So constant I will take outside. So dv by dt. Here we can write dv by dt. That means rate of change of velocity. Rate of change of velocity with respect to time. Now, okay, so f equals to m into what is rate of change of velocity? We know the rate of change of velocity is equals to acceleration. Acceleration. So dv by dt will be equals to a. Okay, dv by dt equals to a. So this is the equation of force for a body of mass m and acceleration a. Okay, now okay, so what will the unit of force? Unit of force, suppose we write in CGS system, we know mass gram and acceleration centimeter per second square. So in CGS system, gram centimeter per second square, we write this unit as a dyne. Okay, so in CGS system the unit of force is dyne. Okay, so in SI system, so what is the force unit? Kg meter per second square. So we can write this kg, we write this kg meter per second square as Newton. Okay, Newton. So just do one thing, just convert 1 Newton to dyne. 1 Newton to dyne. How much dyne? Okay. Okay. So just go through this today's lecture. So if you have doubt, then you can ask me. So okay. So for today, Thank you all.